Hello everyone, this is Abhishek Mahanti and you are watching Padarth Vigyan. So students, in this video we are going to solve this question. This question is from the chapter Electrostatics. The question is, an infinitely long positively charged straight wire has a linear charge density lambda. An electron is revolving in a circle with a constant speed v such that the wire passes through the center and is perpendicular to the plane of the circle. So we have to find the kinetic energy of the electron in terms of lambda. Lambda means the linear charge density of the wire, and then we have to draw a graph of kinetic energy as a function of lambda. So it is given that we have an infinitely long charged straight wire like this. Suppose this charged wire is positively charged and it has a linear charge density lambda. Lambda is the linear charge density, means the charge per unit length. An electron is revolving in a circle with a constant speed v such that this wire passes through the center and is perpendicular to the plane of the circle. So the electron is revolving around this charged wire like this. This is the circular path in which the electron is revolving, and you can see that this wire is passing through the center of the circle and it is perpendicular to its plane. Suppose r is the radius of the circle in which the electron is revolving. So we have to first find the kinetic energy of the electron in terms of lambda, and then we have to draw the graph of kinetic energy as a function of lambda. So first let us tell me what is the electric field due to this charged wire at a distance r from it. So we know that the electric field due to an infinitely long positively charged wire at a distance r is given by E equal to lambda divided by 2 pi epsilon naught r. This is the formula for the electric field, and the electron is revolving here. The distance of the electron from the wire is r. So at this position the electron will experience electric force. That electric force will be attractive one because electron is negatively charged particle and this wire is positively charged. So definitely this wire will attract the electron, and that attractive force, the electrostatic attractive force, will be how much? It will be charge of the electron into electric field. So charge is E and electric field is this much, lambda divided by 2 pi epsilon naught r. So the electron will experience this amount of attractive force when it is revolving in that circular path or circular orbit. So we know that when a particle moves in a circular path, it requires a centripetal force. The centripetal force is always along the radius and towards the center. So when the electron is revolving in this circular path, it must require a centripetal force. The formula for centripetal force is mv square by r. It is given that the electron is revolving with a speed v. So mv square by r is the required centripetal force, which is along the radius towards the center. And you can see that this electric force is also acting along the radius towards the center. So we can say that in this situation, this electrostatic attractive force provides the required amount of centripetal force. So I can say that this Fc is equal to Fe. That implies mv square divided by r equal to E lambda divided by 2 pi epsilon naught r. So r will cancel. We will get mv square is equal to E lambda divided by 2 pi epsilon naught. And the question is, you have to find the kinetic energy. We know that the formula for kinetic energy is half mv square. So half into, what is mv square? Mv square is this much, E lambda by 2 pi epsilon naught. So multiply mv square here, E lambda by 2 pi epsilon naught. The answer will be E lambda divided by 4 pi epsilon naught. So the kinetic energy of the electron is found to be this much, E into lambda divided by 4 pi epsilon naught. Then we have to draw a graph of kinetic energy as a function of lambda. So if you look at this formula, kinetic energy equal to E lambda divided by 4 pi epsilon naught. Here E means the charge of electron, it is constant, 4 is a constant, pi is constant, epsilon naught is also constant. This lambda can be changed. If I use different values of lambda, then the kinetic energy will change. So kinetic energy is directly proportional to the linear charge density or lambda. So if I draw a graph between the kinetic energy and lambda, let us take lambda along x-axis and kinetic energy along y-axis. So the graph will be a straight line passing through origin, because if lambda is 0, kinetic energy will be 0. So the graph starts from origin, and you can see that kinetic energy is directly proportional to the first power of lambda. So the graph will be a straight line passing through the origin. So in this way you can solve this question.